Hello everyone, my name is Sachin Chhabra and I'll be presenting our paper Generative Alignment of Posterior Probabilities for Source-Free Domain Adaptation, or in short called GAP. GAP is a generative approach that captures the relation between source categories and forces it on the target data. Most of the existing approaches perform alignment in pixel or feature space, but GAP works in probability space. It aligns the posterior probability space of the target domain to source without any source data. One of the biggest benefits of GAP is that it does not introduce any new hyperparameters and hence does not require any additional hyperparameter tuning. Another benefit of GAP is that it can also be applied to the source present setting. How GAP works is first in phase A, we train a classifier on the source data. Next, in phase B, we freeze the source classifier and use a conditional GAN framework to train a conditional generator that can mimic the source probability distribution for each class. Finally, in phase C, we freeze the conditional generator and unfreeze the feature extractor part of the classifier. We use the conditional generator to generate synthetic source probabilities, and we use the classifier to generate target probabilities. We perform adversarial alignment of the target probabilities with the synthetic source probabilities. This aligns the target probabilities with source, and it also improves the target performance. Next, we show results on various datasets like office, home, Vista, digits. We can see that the GAP outperforms most of the compared approaches. Another advantage of our approach is that it can handle small mini batches. Like for example, in this case, we have a task of office home transfer, and it has 65 classes. As the mini batch size decreases, it gets difficult to contain sample from all the classes. As the batch size reduces, we can observe that that GAP has much less drop in performance compared to short IM. GAP does not show any significant performance drop till the batch size reaches 20. Here we show the t-SNE plots for feature space and the probability space for our approach in various phases. In the first row, we can see that the target features and the probabilities that are shown in green are quite spread around. We train our source replicator in orange and then use it for the target adaptation. After the adaptation, the probability space of the target domain gets clustered, and it also clusters the feature space. Finally, we show the results for the source present setting. Here, since the source is present, we can directly perform alignment of the source and target domain in the probability space. Also, we can use techniques like knowledge distillation, label smoothing to further boost the performance. We can see that despite being a simple approach, GAP outperforms recent source present approaches like SIMNet, DADA. Thank you for your time. Please let us know if you have any questions.